In this lesson we're going to look at question 13 and some more questions after that. So to pass quality control inspections, this set square must have a perfect right angle. All necessary measurements are given in the diagram. Will this set square pass quality control? So basically what you have to do is use Pythagoras' theorem. Now if Pythagoras' theorem works on this right angle triangle or non-right angle triangle, then we can prove and say it's a right angle. If Pythagoras doesn't work, it's not a right angle triangle. Now Pythagoras' theorem suggests that when you square that one and add the two answers, you end up with that one squared. So our first job is to label the sides in the triangle. I don't think in your assessment they're labelled, so label it A, B and C, or whatever combination you want. I've just gone for A, B and C here. Now AB, one of the shorter sides, is 10.2. BC, the other shorter side, is 6.2. This here would be the hypotenuse opposite the apparent right angle if it was one, and that's 14.4. I always leave that to the bottom one, the longest side. So square all the numbers. 10.2 squared is 104.04, just use your calculator. 6.2 squared is 38.44, and 14.4 is 207.36 when you square it. So what you want to do is you want to look at these two. If you add these two numbers, it should come to the one below if Pythagoras works on it. Now clearly here, these two numbers don't add to that one there. So you need to write a statement. Since 10.2 squared plus 6.2 squared is not equal to 207.36. Or you can write AB squared, since AB squared plus BC squared is not equal to AC squared, that's also okay, which I'm not going to write. By the converse of Pythagoras, the triangle is not right angled. But most importantly, does the set square pass quality control? No, it won't, because it's not right angled. Okay, question 14. The diagram below shows the design stages of a kite. Given that angle STU is 127 degrees, calculate angle SVU. So that's the one in the middle, is V. So I want this one at the bottom. Now, we've got a tangent line here meeting a radius, which is at 90 degrees, and on the other side a tangent line meeting a radius at 90. Now, angles in a four-sided shape always add up to 360. So because of that, if you do 360, take away all of these added together, you'll get your answer. So add all of them up, they come to 307, do a takeaway, 53 degrees.